Okay, we continue with modeling word problems algebraically. Tom's got a bunch of money. He's got $9,600. He invests some of it at 4% a year. He invests some of it at 10% a year. He ends up earning a total of $528 of interest. So, how much? Who much? Who much? Yep. How much did? They can't hear you. They can only hear my voice. The mic doesn't pick it up. So YouTube, they all laughed at me because they wanted to make it sound like I was an idiot of a person for making that mistake. So I probably wrote the notes while I was watching a Vikings game, and the Vikings are so amazing and awesome that it was just, I just made the mistake because I was too wrapped up in the game. Unlike the Packers, who are boring and stupid. Who does? All right, here we go. So, what do you guys think? What do you want to do here? Oh, everybody's going to this. Everybody's going to amount is equal to principal times 1 plus a rate divided by n raised to the nt power. Something like that, right? Okay, because Liz is a genius. That's how she remembers it. So now it's like, what do we do? That unfortunately is not going to work. Um, for example, one of the worst professors I ever had, he did give me one piece of advice that was really good. He said, when you don't know how to do the problem, just do the problem. And so his idea was this. Like, if you had $9,600 to invest, that would mean that maybe you put, like, say, 6,000 here, and you put, say, 3,600 there. Is that right? So 6,000 and 3,600 would make a total of 9,600, right? Well, we don't. I'm just throwing a number out there. I'll, watch. So, Jesse, you're absolutely right. But in this situation, you would then take 4% times that and 10% times that, and that would then give you your interest, right? So I don't know how much I put in at 4%, and I don't know how much I put in at 10%, but I do know it adds up to 9,600. Right? So this is before he invested, okay? He put A in and he put B in, a total of $9,600. You just put them in at different rates, okay? Now, we have a secondary problem. So this is our total amount. But then we have another amount. That's that $528, and that's the interest that he earned. So if he invested 6,000 at 4%, how would you figure out how much interest he actually got? Everybody should know the answer to this one. Yeah, you multiply it by 0.4. 0.4 times 6,000 would tell you how much interest he earned. 0.04. So 0.04 times whatever you invested into A plus 0.1 times whatever you invested into B is equal to 528. So the idea is we have two unknowns, therefore we need two equations. And now you have two options for solving this. You can use a linear combination or you can use substitution. Most people in this situation like to use substitution. If you subtract an A from both sides, you get B is equal to 9,600 minus A. Now I can plug that in for B. I have 0.04 times A plus 0.1 times 9,600 minus A is equal to 528. I substituted this in for B, since B was equal to that. So 0.04A plus 960 minus 0.1A is equal to 528. 0.04a and negative 0.1a, negative 0.06a, plus 960 equals 528. $528 minus 960 and divide by negative 0.06. And I get 7,200. So what does that mean? He invested $7,200 at 4%, and how much at 10%? There you go. So if we were to look way back at the very beginning, here it talks about consecutive numbers, area, shapes, similar triangles. But today, we look at mixture of money. We're also going to look at distance, rate, and time, and work, those three pieces. But this is a different type of problem, mixture of money. And we always set up two equations in those situations. So different class. We're headed to chemistry, okay? And so in order to model it like the last problem, I'm going to have two equations. The first equation is going to have a total amount. What total amount do I want? What's the total? I want 300 milliliters. Okay. And I have some from container A at 60%, plus some at container B. So maybe it's like 200 and 100. Maybe it's 120 and 180. Who knows? Okay? But then I need a second equation, and the second equation has to do with the amount of acid that I have. How much acid do you have? 50 is the most common response. Most everybody goes for 50. But it's 50%. So 50% does not tell me how much acid. Okay, so 50% doesn't tell me how much. So how many milliliters of acid do I want? Yeah, 150 of the milliliters must be acid. Well, what percent of A will be acid? What percent of B? So now I have two equations. Okay. And again, I can use linear combination, or I can use substitution. I'm going to use linear combination. What could you multiply the top through by to use a linear combination? Sure, so I get negative 0.3 times A minus 0.3 times B is equal to, let's see, negative 0.3 times 300, I bet is negative 90. I'm going to trust my arithmetic there. And then I don't have to do anything to the bottom one because I made a smart choice for the top. Equals 150, and we will add those together. And to get 0.3A is equal to 60. Dividing by 3/10 is the same thing as multiplying by 10/3, so I'm guessing we get 200. 200. So what does that tell me? And 100 milliliters of 30%. Do you see how those are similar? Yeah. Okay. All right, three more problems. We're going to do 10, 11, and 12. This one, I want you guys to talk about together for about a minute and a half with a partner to try to say something intelligent about the problem. So John can paint a house in 32 hours, okay? Eric can paint a house in 24 hours. how long will it take them to paint the house together? You try to come up with something intelligent to share with the class. Doesn't have to be the answer. Maybe you could come up with the answer. I don't know. Take a minute and a half, think and talk about it. Ready, set, go. It's kind of a challenging problem. And so one thing we're going to do when we do work problems is we're going to reference a rate and time. And really we have this formula. Rate is equal to distance divided by time, or rate is equal to the amount of work you do divided by time. If we equate distance to work. And so therefore, rate times time is equal to the amount of work gets done. And so if I take John's work and add it to Eric's work, how many houses get painted? One. That's what we want to accomplish. That's the amount of work we want to get done. So we're going to come up with a rate times time expression for John, and we're going to come up with a rate times time expression for Eric, and we'll get 1. Okay? Well, we need that expression. The rate, John paints 1 house every 32 hours. So that's his rate. 1 house every 32 hours. Do we know how much time they spend painting together? No. So times time. That's what we're trying to solve for. That's the variable. Plus, Eric's rate would be 1 house every 24 hours. So 1 house every 24 hours times time. And that should equal a total of 1. So it's like t over 1. So I have t over 32 plus t over 24 is equal to 1. How do I solve that kind of equation? Common denominators. What do 32 and 24 both multiply to? Very good. It's 96. And so 32 times what is 96? 3. So 3t plus, what do you multiply 24 by to get 96? 4. So I get 7t over, not 24, 96, excuse me. That's my new denominator. All right, so I'll multiply top and bottom by 96 over 7. I get t is 96 sevenths. Which if we use our calculator, 96 divided by 7 is 13.71. So we do have an answer here, okay? It takes them 13.71 hours to paint it together. Does that fit within kind of our estimation, our parameters for what we thought might be right and wrong? It does. It does. So, trying to think about a problem in that way is very useful. Well, now Matt and Sue, they can paint a house together in 5 hours. They're professionals. John enters the problem again, apparently. We'll say Matt, because, yeah, I must have been watching the Vikings game again when I was doing this. So Matt and Sue can paint a house in 5 hours if they work together. If Matt can paint a house twice as fast as Sue's slow, how long would it take Matt to paint the house alone? Well, how is this problem different than the last one? Yeah, we're given the time and we're trying to find the rate. So I still want to set up rate times time is equal to the amount of work that gets done. And if I have Matt's work plus Sue's work, that should be equal to 1 house being painted. And so Matt's work is his rate times his time. Well, Matt and Sue. So Matt paints one house every H hours. We don't know exactly how many hours it is, right? But Sue paints one every 2H. She's slow. Now, there's another way to organize this. Some people would say, well, Sue paints one house every H hours. Then Matt would paint two houses every H hours, right? Whether you set it up like this or this, you'll get the same answer, okay? But there are multiple ways to set it up, okay? So, um, so we need, it says rate times time. I have my rates. What's the time? 5 hours for each one. So for Matt, we have his rate, 1 over h times 5, plus Sue is 1 over 2h times 5 is equal to 1. Maybe Sue's not slow. Maybe she's just a lot more careful. Maybe Matt is sloppy. Okay, all right. Natalie is thinking that, okay? It's not possible that a guy could be faster than a girl in this situation, right? Okay, all right, very good. All right, so we have 5 over h then, plus 5 over 2h is equal to 1. You tell me. Well, 2h, so I've got 10 over 2h. So I get 15 over 2h is equal to 1. Or 1 over 1. Cross multiply, we get 2h is equal to 15. H is 7.5. Does that answer the problem? Yeah, if we plug this right in, Matt paints then one house every 7.5 hours. So I just cross multiplied. So I have 15 over 2h is 1, or 1 over 1. Cross multiply. So how long would it take Sue? 15 hours. Grace? Which part? Yeah. It's okay. We're really, what's maybe confusing about it is that we came up with time for an answer, and yet time was in the problem. But really, this is more or less a rate that we came up with. One house every 7.5 hours. So you're good. All right. Let's try problem 12. Well, wait till you get to a homework problem and then see if it's still an issue, okay? All right, two planes are flying toward one another. Longest somebody's been on a plane here. Anybody? Longest. Yeah. This is not that bad. They're going from L.A. To New York. And there's another plane going from New York to L.A. The plane going from L.A. is traveling at a rate of 500 miles an hour. The plane from New York is heading at a rate of 650 miles an hour. Okay, how long have they been flying when they meet if the cities are 2,450 miles apart? Yep, just a nice wave. No, planes will not contact each other, okay? So there's a couple ways to solve this. And I'll admit, if you find a different way of solving it, that's absolutely fine. There's actually probably a little bit easier way of solving it that I'm going to show you, but I don't think it sets up the strategy very well. So I need a volunteer. All right, Grace. Grace, over by the door. Okay. Grace is going to be the plane. So you guys said that their times are going to be the same when they meet, not their distances, not the rate. And then if we divide both sides by r, we get t is equal to distance divided by r. So because their times are going to be the same, I'm going to choose to solve for time in this scenario. So the time for the LA plane is going to be its distance. Do we know what distance it's flown? No. So we'll call that x, and we'll divide it by its rate. Do we know the rate? 500. And for this one, time is equal to, do we know its distance? What's that? We'll go y over 650. And if the times are the same, we should be able to set them equal to each other. So x over 500 is equal to y over 650. But what's the problem? We've got two different variables, right? Well, that's too bad. Well, if that's x, then we got to figure out an expression for this that has x in it. So that's just where they meet. What'd you say? Sorry. So suppose the plane from LA traveled 1,000 miles. How far would the other plane have traveled? What did you do to find that out? You subtract it. So if the plane from LA has traveled x, how far will this plane travel? 2,450 minus x. So now we have an expression that involves x. So now I can change this. I have x over 500 equals 2,450 minus x over 650. How do I solve that? Cross multiply. And here we go. I have 500 times 2,450. I get 1,225,000. It's my bank account. Minus 500x equals 650x. I could solve that. I've got 1,225,000. My number of Twitter followers. Equals 1150x. And so I'm going to divide both sides by 1150. Whoop. Got it. And so I get x is, yes, we cross multiplied. 500 times that and 500 times that. And so we get x is 1,065.22 miles. Have we answered the question? What is the question? What is the question asking? It's asking for the time. Well, fortunately, we've got a nice equation that will tell us the time. That's how far the plane from LA has traveled when it meets the other plane. But yeah, if we simply just divide by 500, that will tell us then the time. 2.13 hours. Is the total time that they've been traveling. We are not going to do that problem right now. Charlie wants to rob a bank. Right here. So, here's the schedule for the rest of the few days. Okay? First of all, 12 through 20 is what you can start working on now. 14 is tough. 14 is the only problem that I haven't modeled for you. So the question is, what if you encounter a word problem that somebody hasn't shown you directly how to set up? Would you be able to figure it out on your own? So here's what I like you guys try to do. Okay, when you get to 14, if you've only spent 5 minutes, you probably haven't spent enough time trying to solve it. But if you spent 20 and you still don't have a reasonable thought, then might be time to move on to something else, okay? On Thursday or on Wednesday, tomorrow, we're going to finish examples 13 and 14 from our notes. 14 will be challenging. Some of you might feel like crying, okay? But on Thursday, you have a full day to work on your assignment in class and ask questions on the problems that you're struggling with. On Friday, you'll have a full day to work on the study guide, which I will give you right now. And on Monday is the day of your test. So I'm building in these 2 days for you. So you will hope. I appreciate your thankfulness, okay?